Hello everyone. This video is on Knewton Alta assignment, section 1.5 part 2, titled Factor Quadratics with Special Products. So in this video, I'm going to be going over a version of the Knewton Alta assignment for section 1.5 part 2. Please understand that the questions I see in this video may not be exactly the same questions that you see when you work on the assignment yourself. But they should be similar questions, so I'm hoping that watching me go over these examples in this video help you in some way when you're working on the assignment yourself. Okay. So again, here's your, now you're not going to see the word preview. You'll just see section 1.5 part 2 in the title. Where you got your mastery bar telling you how far along in the assignment you've gotten. You have question here with the current objective, right? The objective that this question is on. You can view all the objectives by hitting this down arrow and see your progress on each objective. Looks like there are only 2 objectives here. And beneath each question, you should be seeing a couple of buttons, a few buttons. One is the feedback button, where if you notice something wrong, like a typo or something seems off about a question, you can send feedback to Knewton and they might address it. You will not see this instructor cheat button, right? This is only for me, the instructor. But you will see the more instruction button. So if you're working on a question in a particular objective and you're struggling or you don't remember how to work it, perhaps you should click on this more instruction button and it'll take you to some reading, maybe a video or both, that is related to this objective, and then it'll throw some questions at you where you can still see the instruction, and you can always hit this button and make your way through the assignment using more instruction. Doesn't hurt. And then of course you have submit. When you enter an answer, you'll submit the answer and see if it's right. Alright, so now I'm going to start in this first question. It's on the objective factor a difference of squares, and we're asked to factor the following, right? 64x squared minus 49y squared, right? Now remember, factor means rewrite as a product, right, as a multiplication problem. Alright, so I'm going to go to some paper and we'll write this polynomial out. We have 64x squared minus 49y squared. Alright, so this is on that objective factoring the difference of 2 squares or difference of squares. So here's what a difference of squares will look like in general. A difference of squares. So basically, if you have some expression, say a to the second power, right, a squared, minus, right, it's a difference of squares, so subtraction's involved, and then some other expression squared, right, say b squared, then you should be able to factor that. A squared minus b squared is a minus b multiplied by a plus b. Or a plus b times a minus b. It's a sum times a difference. And you can verify this by distributing the a, or you'd get a squared plus ab, and then distribute the negative b, you'd have minus ab, so the ab's would cancel, and then you have minus b squared. You'd end up with just a squared minus b squared. So this is what we're asked to use for problems in this objective right here. So what I'm going to try to do is, hey, can I rewrite this expression here in this form, this something to the second power minus something else to the second power? All right, so looking at the first term, 64x squared, that's equivalent to 8x to the second power. All right, 8x times 8x would be 64x squared. All right, then minus, and then 49y squared, that's equivalent to 7y to the second power. So now I have the expression looking just like this little form over here, right, where this 8x is like the a in my formula, and the 7y is like the b in my formula. So now all I'm going to do is write the factors out, replacing the a's with 8x and replacing the b's with 7y. So this should factor to a minus b, so 8x minus 7y, multiplied by 8x plus 7y, a plus b. And again, you can have these in either order. You can write 8x plus 7y times 8x minus 7y. And I'll put this in a little box because this is what they wanted us to do. Factor the expression. Now, you should always be checking your answers. Right? Now, to check if you've factored correctly, you multiply and see if you get the expression that you started with. So if I take 8x minus 7y and multiply it by 8x plus 7y, let's see what happens. So first I would distribute the 8x, right, to this 8x plus 7y. That'd be 64x squared plus 56xy. Right, now I'm done with the 8x, and then I move over to the negative 7y and distribute that. That'd be minus 56xy, and then minus 49y squared. And look at this, right? See the 56xy and negative 56xy, those add up to 0. So those are gone. And I'm left with 64x squared and then minus 49y squared, and that's exactly what I started with. All right, so the factorization we wrote was correct. All right, so that's what I'm going to enter. Right, I'm going to enter this factored form here back in the assignment page. So in parentheses, right, 8x, minus 7y times, and then parentheses again, 8x plus 7y, and this should be good. And we'll submit and see if we got it right or not. Hooray! It'll tell you if you got it right or wrong, and then there will be an answer explanation. Please read through these, whether you got it right or wrong. If you got it right, just read through it to make sure you got it right for the right reasons, right, that you didn't just get lucky. Understand why you got it right. And of course, if you got it wrong, definitely read through the answer explanation, trying to figure out where you went wrong, why you were wrong, understand it. So that way you'll do better in the future, hopefully. Alright, so let's continue on. Alright, so the next question is on the other objective. Factor a perfect square trinomial. Alright, so I'll discuss what that is in a second. So the question here is, which of the trinomials below is a perfect square of a binomial? Alright, or a perfect square. Okay. So let's just write out what a perfect square trinomial is first. A perfect square trinomial. Takes one of the following forms. One is, something squared, so say a squared, plus 2 times that a times another expression b for the middle term of the trinomial, and then plus, and then that b again squared. Right? So here's a 3-term polynomial, trinomial, and the reason it's called a perfect square is because it can be written as the same factor twice. This is a plus b times a plus b. Right? The same factor twice, but usually you don't write out the same factor twice, you just write it as a square. So this is the quantity a plus b squared. Right? Thus the name perfect square. A perfect square is just any expression that can be written as the same factor twice or something to the second power. So you have a trinomial that is a perfect square. And you can check this, by multiplying. Take a times a times b, and then b times a, b times b, and add them up, and you get a squared plus 2ab plus b squared. Or, the only other form of a perfect square trinomial is basically the same thing, except for there's a minus in front of the second term. So it's, something squared, a squared, minus 2ab, 2 times a times b, minus, and then always a plus here at the end, plus b squared. If any polynomial takes on this form, then it is also a perfect square trinomial, but the two factors this time are a minus b. It'd be a minus b times a minus b, or in other words, written as a square, as a perfect square, a minus b, that quantity squared. Right? Okay, so we're looking for polynomials, that take on this form. Now the question was, which of the trinomials they gave us is a perfect square trinomial or a perfect square of a binomial. You see over here it's a binomial squared, right? 2 terms to the second power. All right, so the first of these was negative 3x squared minus 6x, plus 1. Does this take on either of these forms? Now you got 1, which is, 1 squared, so maybe the b is 1. But this is not a perfect square. This is not a nice square. Negative 3x squared. Not a square. Or a perfect square, I should say. Right, I can't take any number and square it and get negative 3, or any real number anyway. So no on that one. That's not a perfect square trinomial. All right, the next one they gave us was 4x squared minus 12x plus 4. Okay, and this is looking better already. The first term I can think of as 2x squared, right? So that's like the a squareds minus, and then the last term I can think of as plus, 2 squared. All right, so if I think of the first, this 2x as a and the 2 as b, if the middle term is minus 2ab, then we have a perfect square trinomial. Well, let's see. Is 2 times 2x times 2, where a is 2x, b is 2, is that the middle term? Nope. Because this is minus 8x, isn't it? So 4x squared, so 4x squared, minus 8x plus 4. This is a perfect square trinomial. This would be 2x minus 2 to the second power. But this one they gave us here, this is not in one of these forms. This is not a perfect square trinomial. Right. And actually, I would factor out a 4 from this first before factoring, but you always factor out the greatest common factor first. Let me point that out. How about the next term? Right, the next one they gave us was 4x squared minus 24x plus 9. And again, the first and last term look pretty good. 4x squared, that's 2x to the second power. So 2x is like the a again. The last term, plus 9, that's plus 3 squared. So again, if I think of 2x as a and b as 3, is the middle term minus 2ab, minus 2 times 2x times 3? Are these the same? Yes. No, sorry. Eeps. My apologies. 2 times 2x times 3, that's 12x. That's 12x. So 4x squared minus 12x plus 9, this is a perfect square trinomial. This would factor to 2x minus 3 to the second power. But this one here with the minus 24 in the middle, again, is not a perfect square trinomial. So far we're striking out. How about the next one? Right, the next one they gave us was this. It's 4x squared plus 6x plus 9. So again, we have 2x to the second. We have plus 3 to the second at the end. If this middle term is plus 2ab, plus 2 times 2x times 3, then we're good. But again, this is 12x, not 6x, just like the earlier one. So once again, no. Right? 4x squared plus 12x plus 9. That's a perfect square trinomial. That would factor to 2x plus 3 times 2x plus 3, or 2x plus 3 squared. But 4x squared plus 6x plus 9, no. Right? Then the last of these they gave us was 49x squared plus 70x plus 25. Now 49x squared is good. That's 7x to the second. The 25 is good at the end, right? That's plus 5 squared. Now, if the middle term is 2ab, plus 2 times 7x times 5, we're good. Or minus, but here it's a plus. Is 2 times 7x times 5, is that 70x? Yeah, this time it is. This time it is. That's 14 times 5, that's 70x, or 10 times 7, 70x. So this is a perfect square trinomial. And if you were to factor it, it would factor to 7x plus 5 squared. It would be 7x plus 5 times 7x plus 5. But that is not what we were asked to do. We were just asked to identify if it was in that one of these two forms, which it is. It's in that first form, where a is 7x and b is 5. All right, so after all that, the only one that actually fits is the last one. Okay. Great. And again, they go through. Now they're using lowercase a's and b's. I just use capital A and B a lot. All right. Okay. Next question. So it's a two-parter. Actually factor it, and I wrote that out. Right, now that we found a perfect square trinomial, how does it factor? Well, again, a was 7x, b was 5. This is in that first form. It factors to a plus b times a plus b, 7x plus 5 times 7x plus 5, or just the quantity 7x plus 5 squared. Right. So 7x plus 5, and then to the second power. Just make sure that's in the exponent. And there are some there's the exponent thing here, but you can also use the caret button above 6. Submit. That should be good. Hooray. And again, please read through your answer explanations. Alright, so next question. Alright, so now we're back to the objective factor a difference of squares. See, we've already made a little progress because I answered one of these earlier. Now remember, if you answer things wrong, it backs the progress bar up, and then you'll have to do more questions until you get them right. So try not to guess on these things, right? Really work on them. And again, if you're struggling, click on the More Instruction button. Alright, so once again here I'm going to pull out my difference of squares page, and we'll write this polynomial down. Alright, so there's the difference of squares, and this time we're given 49x squared minus 100. Now they have no greatest common factor, these two terms. That's the first thing you should look for. Now I notice it's a difference of two terms, so it might be one of these differences of squares. Well, let's see. 49x squared, that's 7x to the second power. So treat A like this, 7x. Minus, and then 100 is 10 squared, right? So the B from my formula is 10. So the way this would factor is one is with 7x minus 10 times 7x plus 10. Right, a minus b times a plus b. Or again, you can do the other order if you want. 7x plus 10 times 7x minus 10. It doesn't matter what order factors come in. All right, and that's what I shall type. All right, so back on the assignment page, quantity 7x minus 10 times 7x plus 10. And we'll submit. Hooray. All right, and again, please read through the answer explanations. Next question. All right, so we're still on the same objective here, factor a difference of squares. So I'm going to keep that difference of squares formula up and write this polynomial down. So we have here, it's 121 x squared minus 9y squared. All right, again, two terms, there's a minus here, I see some squares, there's a good chance it's a difference of squares and it can be factored. Now 121x squared, that first term I can rewrite as 11x to the second power, right? 11x times 11x would be 121x squared. Minus 9y squared, that's 3y to the second power, right? 3y times 3y would be 9y squared. So I treat 11x like the a, and I treat 3y like the b, and factor, a minus b, 11x minus 3y, multiplied by a plus b, 11x plus 3y. And again, please don't forget to check these with, I haven't been checking them because I know I'm doing them right, but you should be checking your results when you're first learning. Multiply them and see that you get 121x squared minus 9y squared back. All right, but this is what I'm going to type, what I just circled here. All right, so back on the assignment page, 11x minus 3y times 11x plus 3y. Not EY, 3y. Okay. Great. All right, then next question. All right, looks like we got, we're 3/4 of the way, and it looks like we just got one more question here on this difference of squares objective. So I'll keep the difference of squares up. Let's pull up the polynomial they're writing here is 25x squared minus 16y squared. Again, the first term I can think of as 5x to the second. Second term, 16y squared is 4y to the second, so I do have a difference of squares, and this will factor then to 5x minus 4y times 5x plus 4y. Or switch them, 5x plus 4y times 5x minus 4y. Either one is fine, but there's the factored form of that polynomial. And you can check by multiplying. Right, so I'll enter 5x minus 4y times 5x plus 4y. And that should be good, and that should be it for that objective. You know, for most objectives, you get around 4 questions correct, you'll complete that objective, as long as you don't get anything wrong. Again, if you get things wrong, it'll back up the progress bar, and you'll have to do more problems. Alright, so the rest of the questions should be on perfect square trinomials. Alright, so here's another one where we're asked to identify which one of these is a perfect square trinomial. Alright, so just like the last example with perfect objective. Alright, so here were the perfect square trinomial forms. Again, let's leave them up, and then we'll go through each one of these and see which ones are in one of these forms here. So the first one we're given is 9x squared plus 48x plus 16. 9x squared, that's 3x to the second, that's a nice square. The plus 16, that's plus 4 squared. So I'm going to treat 3x like a and 4 like b, and hopefully the middle here is plus 2ab. Let's see, plus 2 times 3x times 4. What is that? That's 24x, not 48x, so that's no good. Alright, if that was 24x, it would be a perfect square trinomial. Alright, so let's move on to the next one. We have 16x squared plus 8x plus 4. So again, the first and last term are the ones I'm checking first in all these. These are nice. You know, these are nice squares. That's 4x to the second for 16x squared. The constant term is 2 squared. So I'm going to treat a like 4x and b like 2, right? And c is the middle term plus 2ab. Plus 2 times 4x times 2. What is that? That's 16x, not 8x. So that's no good. That is not a perfect square trinomial. All right, if it were 16x in the middle, then it would be, but it wasn't. All right, the next one we're shown here is 49x squared minus 42x plus 9. So again, the first and last term we're working out with the a squared and b squared. 49x squared is 7x to the second. The plus 9 is plus 3 squared. So I'm going to treat 7x like a and 3 like b, and see if the middle term is minus 2ab, right? Minus 2 times 7x times 3. And what is this? This is minus 2 times 21, that's 42x. Bingo. This is it. So I'm going to stop. It just said, which one of these is a perfect square trinomial. I said select the correct answer. So this is it. I don't have to check the other two. And I might as well factor it now, because they're going to ask me to factor it in a second, I'm sure. Remember, a squared minus 2ab plus b squared factors the the quantity a minus b squared. So here a is 7x, b is 3. So this is going to factor to 7x minus 3 squared. And you can check by multiplying. Take 7x minus 3 and multiply it by 7x minus 3 again, do your foiling, and you should get 49x squared minus 42x plus 9 back. Alright, so the only one of these that should be a perfect square trinomial that was in one of those forms is that one. Great, and again read through it. And then factor it. Right, they have a second part where they say write it as a square. And that was 7x minus 3 to the second power. Right. Wonderful. And that should be good, and I think that should be it. We'll see when I hit continue here. And indeed it is, right? So both objectives are complete. The assignment's done, and I'll move on to the next one. And as I said at the top of the video, right, please understand that the questions I saw here in this video, the examples I went over, are not going to be exactly the same problems you'll see necessarily. But the way I did them, the objectives they're related to, right, should be the same. should be very similar. So I'm hoping that watching me go over these here help you in some way when you're asked to do this assignment on your own. And thank you very much for watching.